Hey everyone, my name is Prajwal Walia and welcome back to my channel. So today we'll solve a real system design interview question from scratch. The question will be design a URL shortener like Bitly or TinyURL. And I'll approach this exactly the way I would in a real interview. So we'll start with requirement gathering, discussing functional and non-functional requirements, estimating the scale, building the architecture step by step, and then discussing the trade-offs and finally seeing how the system will actually behave. So let's imagine I'm sitting in an interview room and the interview has just asked me, can you design a URL shortener? Now, before jumping into the design, I'll like to clarify the requirements. So we will have functional requirements. Okay, functional requirements. So these functional requirements can be user submits long URL and we convert them into short URL. Okay, and the second one will be user access long URL via the short URLs. Okay, this is our functional requirements. Okay, the spelling is wrong. Okay, now next is our non-functional requirements. So non-functional requirements will be simple as our URL shortener will be more of a read heavy kind of system, so it needs to have high availability. Second, low latency. Third, we should be able to scale it horizontally. Okay, and the last, as I said, it should be a read heavy infrastructure. Okay, so these will be our functional and non-functional requirements. Now let's talk about our second most important thing, which is capacity estimation. Okay, a lot of people miss this, so yeah, I'll talk about the capacity estimation now. Now let's assume that this is a quick estimate. So let's assume that there are 10 million URLs, like we can say 1 million as well, but I'll keep the track of 10 millions. Okay, now second is read to write ratio. Okay, it will be 100 to 1. Okay, but it's an assumption. Now this means we will be serving around 1 billion URLs, okay, every day, each day. So this immediately means that our system is very read dominant. So result, read dominant systems. Okay, now this is our capacity estimation. We have everything with us. Okay, now let's talk about the initial design, how you will design this. So let's keep it simple. We will have user, we will have the load balancer, then we will have the server, and then we will have the database. Okay, now user makes the request, it goes to a load balancer, it distributes the request to the server, and server fetches the data from the database. Now what happens, this at this point it is quite a working system, right? So it's good for, let's say, I'll say 100 users. So let's try the simulation, and we can see there are a lot of production risks, okay, which is evident because this is a very basic system. Now let's walk through the URL creation. So user submits a long URL, right? Then request reaches the URL service, then URL service generates a short code, and then mapping is stored in the database. So this, and by this short URL is returned. Now let's talk about the redirection. Okay, user opens the short URL, user service fetches original URL from the database, and then user gets redirected to that particular long URL. While this works, I already see a bottleneck. Okay, now first bottleneck is this is a read heavy system. If every redirect hits the database quickly becomes a bottleneck, right? So to avoid this, I'll introduce caching. So I'll pick up the cache, I'll keep it over here, and instead of server directly hitting the database, I'll make it hit the cache. Okay, so what will happen is the entire flow gets redirected through the cache hit, it returns the data immediately. If there's a cache miss, then it will go to the database, and from the database it will fetch the value and then return to the server. Okay. Now second improvement, database scaling. Now let's assume we are storing billions of URLs. A single database won't be enough. So we need to introduce replicas. So what I'll do, I'll go here, this is my primary database, I'll bring on the replicas. So this will be a replica, I'll mention it over here. Alright, and we'll also make it a replica. So I have just introduced one replica, we can introduce multiple other replicas as well. But this will be, as this is a master slave structure, so the replicas will be connected to our database itself. And replica, cool. Now write continues to go to the memory, but read request is directly sent to the replicas, right? This allows us to scale complete reads independently. Now the third improvement, which is our ID generation. Now let's discuss how we generate short URLs. Many people use database auto incremental IDs, right? But that introduces coupling with the database. So instead, I'd introduced a ID generator. So over here, let's say we'll pick up a service itself. We'll name it ID generator. Okay. Now, what will happen is that let's keep the ID generator for here as of now. Okay. So what happens is that this generator provides unique IDs. Okay. And what happens is that it also uses, first of all, it will also use a base 62 string, and this will give us short URL which will be unique, and it will not rely in any ways to the database generated IDs. Okay. ID generator will go here. So database replicas, it will be more of read replica 2 and read replica 1. Okay. Okay. Now imagine your product asks for click analytics, right? How many clicks, or which URLs are more popular, or which region generates more traffic. The mistake would be updating analytics synchronously during the redirects, right? That would increase user latency. So I'll just introduce a Kafka, okay, Kafka generator, and what we'll do is it will automatically create the analytics. So it's basically I'm introducing queues. Okay, so this will be my queue. It will be called I'll say analytics queue. Okay, so as we are keeping it asynchronous, so we require analytics queue, right? So there will be analytics queue, then I have my service. Okay, this will be my analytics service. Okay, basically I should not keep it here. I should keep it connected with the server because it's more of a different field rather than generating it. So my server will directly connect with this. I'll name this server URL server. Okay, and what will this analytics service do? It will connect to our database. So we can have different database for analytics service as well. But right now let's keep it this one only because everything will be stored inside our primary database. Okay, it's mostly for the read ones, so I'll change it from here and keep it in the read ones. Okay, this makes more sense now. Okay, cool. Fine. Now whenever a redirect happens, we publish an event. The user gets redirect immediately. Analytics are processed asynchronously, and this keeps the redirects fast. So when user adds when user clicks on their short URL, they will directly go to the long URL, right? We don't want this process to be broken, so we start a new asynchronous process which will happen in its own time and in the background, and our analytics event will get updated with this. Okay, now let's assume this becomes a global service, and I don't want that every request comes to my application servers. So what should I do? I'll just simply introduce a CDN. So here's my user, and I'll introduce a CDN. So user can directly access to the CDN, and then that CDN will access to the load balancer. Okay, it's as simple as that. Now, frequently accessed URLs can be stored in the CDN, and it will be more closer to the users. This will reduce the latency and lowers the backend traffic as well. So if I'm asked to draw URL shortener, this is how I'll draw it. Okay, I will have my user, they will be directly hitting to the instead of directly hitting to the server, it will go to the load balancer. So one more thing that can be done here is we can add multiple servers. The reason behind doing this is to load to match the load, to serve the good load. Okay, so URL server 1 and URL server 2. Okay, now load balancer can go to both of these servers. These servers will be connected to the cache, and they will be connected with the analytics queue as well, depending on which we are using. Okay, so this is, I'll say, the final architecture that I'll generate, and we have user, CDN, to load balancer, URL server 1, server 2, analytics queue, and whatnot. Okay, I think we have something here. Yeah, cool. Now I believe this is how it will go. Okay, for me at least. Now if I go for the trade-off discussions, and if I were in a real interview, this is where I discuss the trade-offs. Okay, the first will be my cache consistency. The second thing will be replication lag, because we are using replications like replicas of our database. Third will be the sharding strategy. Okay, the fourth will be analytics throughput, like that's up to you. And the fifth and the most important will be availability versus the consistency. Now interviews can, interviews care more about your reasoning than your final diagram. So I think, yeah, this is what I'll tell you about this one. Okay, so I believe now we can start with the stress testing of our design. So we have completed it. Let's submit the evaluation. Now I see there is score of 50 and there is a lot of point to improve. One is queue add but no worker to consume. Okay, so we'll just come over here and add a worker. We'll connect with this one. There's one more. Storage should be terminal, compute, initiate queries, reliability, view fix, add redundancy, fallback, safeguards. Okay, let's not think about this. We have added the workers in the. Okay, one is rate limiter bypass. So one thing we can do is we can add a rate limiter over here and do this. Now let's try to run the simulation. The score improved and it is 68 right now. So there are a lot of things that can be improved, and using this simulation you get the chance to improve your diagram one step at a time and get a score of 100 as well. Okay, this is up to you. Now I can see my architecture right now is performing not a very well score, but it is a 68 now, and with more iteration I believe we can improve this. So yeah, final verdict I'll give is that this is how I'll actually approach URL shortener system design interview question as a candidate. And yeah, if you would like to practice design like this yourself, I'll add the link to this tool in the comment section, and from there you can go ahead and check it out. Till then, have a really nice day and keep on practicing. Thank you.